Hey everyone, so today we are officially talking about trigonometry. We've been in the past talking about special right triangles in the unit circle in order to prepare us for trigonometry and working with triangles in a little bit different way. So you might be asking, what is trigonometry? You've said that word a lot, but what does it really mean? Well, trigonometry is the study of triangle measures. And we get triangle measures because trigonometry actually comes from the Greek root, the Greek meaning. We have trigon, which just means triangle. And we have metron, which means measure. So you can see, basically trigonometry just means exactly what it says. It's triangle measures. Trigon, triangle, metron, measure. Now, there are three important words to know about trigonometry, and they're kind of the base of how we figure out things with triangles. The way you say these ratios are sine, cosine, and tangent. And we call them the trigonometric ratios because they all tell us the different ways that we can use sides to find angles or to find other sides. So first, let's talk about sine, and I am going to use orange whenever I talk about sine. So we have the ratio of the leg opposite the angle to the hypotenuse. So if we're talking about angle A is right here. So opposite of angle A is going to be this little A right here. And it's the ratio of that opposite leg to the hypotenuse. And the hypotenuse is the longest leg. In this case, it's C. So the way we would write sine A as a ratio is to just write a fraction of the opposite leg over the hypotenuse. In other words, we would just have A over C. Similarly, you'd see the same thing for angle B, except the leg that's opposite of B is little b. So we would have B over C. Now for cosine, I am going to use blue. And cosine is similar to sine, but we have to use the other leg. In a triangle, we have three legs. And for every angle, there's a leg that's opposite and adjacent, and then that hypotenuse that we talked about. So for this one, since we've already used the opposite with sine, we're going to talk about the ratio of the adjacent leg with the hypotenuse. So if we start off with angle A right here, the leg adjacent to it or right next to it is B. So we would write this as B over C. And for angle B, we would have the adjacent is A. So we would write A over C. So you might be thinking at this point, wouldn't cosine of A just be the same as sine of B? Well, think about the measures that we're comparing here, right? We are talking about the opposites versus the adjacent, basically the two different types of measures that we could have. So you're right in thinking that they would be opposite, but we're going to do a couple of number examples to show you how those numbers relate a little bit more clearly. But we have one more before we move on. Our final option for our ratios is tangent. And for tangent, I'm going to use green. But for tangent, we have the ratio of the opposite and the adjacent leg. So we're taking sine and cosine combined to get tangent. So for tangent of A, we would have angle A right here. We have its opposite, which we already said was A, and its adjacent, which is B. So this is A over B, which means for tangent of B, its opposite is B, and its adjacent is A. So it kind of flips itself, B and A. Now, this might seem like a lot to remember, but we have a nice little acronym that goes with this. For sine, we say so, because it's sine is opposite over hypotenuse. So if you put the first letters of all those together, we get so. So you'd say opposite and hypotenuse. For cosine, since it's adjacent in the hypotenuse, we say it's ca. Because it's adjacent, starts with a, hypotenuse, h. So we have ca for cosine, and tangent is toa, because that is opposite with adjacent. So the way that we say this all together so that we can remember how our trigonometric ratios work is we say soka toa, all together in like one big string. Now, I have a couple of examples we're going to go through just to practice finding the ratios for some different triangles. If you want to jump ahead, see if you can't figure these out, and then check back in the video, you can do that, see if you got the right answers. First, let's just look at triangle 1. And the first thing I want to do is look at both the sine ratios. So first, I need the sine of A. Well, here's A. And we said for sine, that's so, opposite over hypotenuse. So the opposite of A is 5, and the hypotenuse is 13. So 5 and 13. Now, but sine of C is going to be the opposite of C. C is here. We have 12 is opposite to C, and we have 13 is still the hypotenuse. So 12 over 13. Now, let's jump down to cosine. If we look at the cosine of angle A, that means we're looking at the adjacent and hypotenuse, which is going to be 12 over 13. And for cosine of C, our adjacent is 5. So we have 5 over 13. So earlier I said that we would look more at how these numbers relate to each other. And again, right now, it looks like the leg ratios match up. The only difference is going to be once I actually use the cosine and sine functions that I have in my calculator. So with that, we'll get to that here in a minute. Right now, we're just practicing setting up some of these ratios together. Last ones, we've got tangent. So now we want to look at the tangent of A. And tangent is toa, which means opposite over adjacent. Opposite would be 5, and adjacent is 12. Well, that means the tangent of C is just the opposite of the tangent of A. So we have 12 over 5. If you want to give these other two examples a try, you can pause here. I've uploaded the key to this notes page so that you can check your answers out there. But the next thing I want to do is go on to, all right, so I am just going to do the first 3 examples on this page. So you can either pause now and try out those first 3 before I get to them. If you want to try out the other 5 problems that are on here as well, I have posted this key to Schoology, so you can check out the key to all of these problems there for your notes for today. So for question 1, we first need to solve for x rounding to the nearest tenth. So that means my decimal will just be 0.1, point whatever. So we want to solve for x. And in this triangle, we have x over here. And the other information we were given is that it is a right triangle. That's good. You can see all of these are right triangles because we first want to start off by just looking at these options. And we're given the angle 28 degrees as well as a side length of 19. Well, this 19 is special though. This is the hypotenuse. And since I'm only really given this 28 degrees as an angle, I am going to use one of my SOHCAHTOAs, one of my trigonometric ratio functions. And since x is opposite of 28, it's all the way across the triangle, we are going to use sine. So, because it's opposite and hypotenuse. So I would set this up to be sine of 28 equals x over 19. Now, if we want to solve for x, we're going to have to get rid of this 19. In other words, we need to multiply it on both sides. So I'm left with 19 sine 28 equals x. Now, what you should do for this one is you should get out a graphing calculator of some kind. Maybe you have that WabbitEmu app that I told you to download. Maybe you already have a graphing calculator. Either way, as long as you have a graphing calculator, you can see mine here is that app on my phone. We first need to make sure that our calculator is in degree mode. So the way that we do that is we go to the mode option here, and you can see my calculator says that it's in radians and not degrees. So I need to go down and make sure that I hit for it to be in degree mode. We'll talk more about the difference between having it in radians and degrees in another lesson, but for today, this is all we need. So now we can get out of here by doing our second function and quit. So now our calculator is in degree modes. We're going to be able to figure out how to find x in this example. So all I have to do is type in the problem exactly as it's stated. 19 sine is its own little button, 28, and you hit equals. So this tells me that the measure length of x should be 8.9 if we round to the nearest tenth. Rounding to the nearest tenth, we want to cut off for this 0.9, and since the next number is a 1, even if we were to round that up to 2 because of these 9s back here, we would still not be able to round that 9 up to the next number. So we would have 8.9 for our first option. For this second problem here, for this second one, we have x, we have the angle 41, and we have a leg measure of 32. For this one, you can see that we have our right angle, but we don't have our hypotenuse across from it. Since we are missing our hypotenuse, that means out of our 3 SOHCAHTOA, we need to use the one that doesn't use the hypotenuse. In other words, we're going to use our tangent, our TOA. So if we look, our angle 41 here is right next to 32, so this is our adjacent, and x is our opposite. So for this equation, we would say that tangent of 41 equals opposite over adjacent, which is x over 32. So our next step, to get x by itself, multiply both sides by 32. So we have 32 tangent 41 equals x. So 32 tangent also has its own little button. You can see the 3 right here in a row. You can see them right there. And then 41 was our degrees, so 41. And we get that the leg measure for x should be 27.81717, yada, yada, yada. But we know that if we're rounding to the nearest tenth, that this is going to be 27.8. For our next problem, I'm going to skip all the way down to number 5. I'm going to skip down to number 5. So for this one, we want to look at x is our hypotenuse. And 15 is not next to 33. It's not next to 33. So that means that this is opposite of the angle 33. So what we have to do is we have to use one of our trigonometric ratios to figure out what our hypotenuse is going to be. Well, in order to do that, I have opposite and hypotenuse, which means out of SOHCAHTOA, the one that has O and H is SO, or my sine function. So we would set this equation up to say that the sine of 33 degrees is equal to our opposite, which is 15 over x. This one's a little bit trickier than our last couple problems have been. You can think of this in a couple of different ways. You can either multiply both sides by x to get x out from being in the denominator. And then you would divide by sine of 33. Sine of 33 is just a number. It doesn't really matter where it goes. It's just telling us that we are using the sine function to figure out the exact number that we're going to have. So this would say x equals 15 over sine of 33. The other way we could have done this is to just take the reciprocal of both sides of our original equation. So if I did that, I would have 1 over sine of 33 equals x over 15. To get x by itself, we'd multiply both sides by 15, and I'd end up with the exact same equation I have over here. Doesn't really matter which way you want to go, whichever you think best works for you will work for me. So now let's get our calculator out here again. This one, again, is a little bit trickier. We need to take 15, divide it by sine of 33. So instead of just writing them all together, we have to make sure we put the divides in between the two. But since they're both just one numbered function, we don't have to worry about extra parentheses or anything like that. We hit equals, and we see that our hypotenuse should be 27.5. X equals 27.5. Now, again, if you want to take a look at these problems here, I have posted the key on Schoology, so you can get all of your work done there. I have a couple of word problems here, too. If you want to give those a practice try, see if you can't figure those out. We can talk about those in class as well if you would like to. It's kind of up to however you want to run your work time and question time. After you've taken these notes, you should log on to Delta Math and practice some of the problems I've assigned for today. As always, you can email me, message me any questions you have, or meet me in our Google Meets during class time.